let me give context to people so we know what you're talking about, right? So President Trump, obviously, one of his main conditions for considering all of this operations inside Iran to be successful is to get the enriched uranium out of Iran. The problem is that after Operation Midnight Hammer in June 2025, it was June, right? It was June? Yes. The nuclear dust or the 60% enriched uranium inside Iran was buried under a lot of rubble, really deep underground, to the point where, according to President Trump, not even the Islamic Republic can get it out of there. According to President Trump, there's only two countries that could get that enriched uranium deep from underground. One of them is United States, obviously. The other one is China. This is what President Trump said just hours ago, by the way. So even if the Islamic Republic wanted to give up the enriched uranium, they couldn't because it's just too deep underground. So you're saying we could get them so deep underground using robots?
I would use them only in the final retrieval phase. You'd still need a lot of equipment just to get down there. You wouldn't have to make a hole as big as the door was. You just need to support the narrow corridor as big as a couple of humans to get in there. But you wouldn't even want to get near that stuff with some of the. We've all seen the little dog Boston Dynamic robots. You would send that in there with a Geiger counter so you can know where it is. Once you get close enough, I put two links in the chat. I don't feel comfortable with sharing my browser because it has too many things in there. But the Boston Dynamics has a thing that they used to call Atlas, a Petman. It's a very humanoid robot that is very capable of navigating these kinds of tunnels. You would only need something as it's only 440 kilos. All right. It seems like a lot, but it's really not. If it was inert, humans could go get that. If you just make the tunnel and send them in there, you need strong humans. But if you get robotics, if you get robots, you can get that out. We do have the technology. I've heard a lot of people be very, how should I put it? Very down on the idea, very they make it harder than it actually could be if you look at exactly what the mission parameters are. Get it out. All right. This isn't going to be spread throughout a long tunnel. They're going to have this stuff all together. It might be 2 or 3 locations within that tunnel. I don't think they would even spread it that far apart because it would just be a bad idea. You would have it probably in one place, maybe in 2 locations in that tunnel, in one location, 2 or 3 places in that location. All you need is to burrow into the tunnels. You wouldn't have crashed every place inside that tunnel. You would just make it impossible to get in or out. So all you need is to burrow down into any place, because let's say there's a tunnel that's, let's put it, a mile long underground. All you need is the weakest point for you to get into that tunnel, and then from there send whatever you need to get in and out. So I think this is a very viable thing that you can do. This is a viable thing. It's not as impossible or does not take as long as a lot of people think.
So let me read
And
this.
I think it's
Yeah, go on, finish, and then let me respond to you.
I think it's a lot more viable than people think. I think it wouldn't take months. It would maybe take 1 month, maybe a couple of weeks could get it done. If you have these engineers, the army engineers are no joke. They have been training for this kind of thing, specifically about Iran. You have people that are in the deltas, that they are not just trainers, that you have people that have been training their entire lives on this specific mission. Go get uranium, right? This is
Yep.
one of the reasons we train deltas is this. The other reason is to train people.
Yeah, but
I think it's very viable.
what I've heard is that the engineers that could do this, who are not soldiers, that need to be with the soldiers, are very few in number, and they're all American, by the way. Let me
Yes.
actually read this to see what the complication is from an engineering perspective to get the nuclear dust. And guys, whenever we say the nuclear dust, we're talking about the 440 kilogram of 60% enriched uranium and residues. Okay, so it's a basically pile of powder. It's not like a pile of powder that it's like sitting in a room that you could just go grab. Okay, so following the 2025 airstrikes on sites like Fordow, Natanz, and also the nuclear site in Isfahan, getting this has been turned into a logistical nightmare, according to the experts I've been reading. Right, so from a structural, chemical, and radiological perspective, these are the challenges that we're having. Okay, so it's like a deep tomb, deep in the ground. So the Islamic Republic's most sensitive facilities were built deep inside mountains, like the Pickaxe Mountain complex, to resist bunker busters. The airstrikes didn't vaporize the material; they collapsed the reinforced concrete ceilings and rock on the centrifuge hulls. So the centrifuge hulls that these were there is now being covered by a whole bunch of concrete. So the challenge is that you aren't just picking up material. You are effectively performing a deep vein mining operation in a structurally unstable, radioactive cavern hundreds of feet underground. So there's also the separation nightmare. This is materials engineering. So getting it that digging is civil engineering. The separation now is materials engineering. So this is a type of other engineering that now you need to get involved with, right? So the uranium was stored as uranium hexafluoride, UF6, gas, and 60% enriched solids. When the facilities collapsed, these materials were pulverized and mixed with thousands of tons of industrial debris and concrete. So the challenge here in engineering terms, the dust is now a trace contaminant in a massive volume of rubbles. To get it out completely, you would have to excavate and process thousands of tons of concrete, heating it to over 500 degrees Celsius. Wow, what the hell? To release trapped particles, a process that is nearly impossible to do covertly or quickly. And then three, okay, then that's the two challenges. We still have more challenges. Chemical and radiological lethality. So basically, safety engineering, third type of engineering, safety engineering. The environment is a toxic cocktail. UF6 reacts with moisture in the air to create hydrofluoric acid. Oh my God, HF, which is highly coercive and lethal. So the challenge here is humans cannot enter without heavy, cumbersome PPE that limits dexterity and work time. Even the snake like robots used at Fukushima struggle in these types of high radiation, obstacle dense environments because radiation eventually fries the circuitry. So this is another problem. Number four, verification and sanitization. This is forensic engineering. So the Islamic Republic has a history of sanitizing sites, raising buildings, replacing topsoil, and using chemical washes to mask residues. The challenge, even if the US digs it out, ensuring that 100% of the 60% enriched particles are gone is scientifically improbable. From an engineering standpoint, you can never prove that the dust is entirely gone once it has been dispersed into the local environment and groundwater. So here's the robotics parts that you're suggesting. So I basically, let's see if the robotics can help. Robots would help keep humans safe, but they cannot solve the core engineering problem. What they can do, small drones and snake robots can scout the unstable terrain, map radiation levels, and identify hotspots without risking human lives. What they fail at why they fail at extraction. So the radiation fries circuits. High level radiation degrades semiconductors and quickly destroys robotic electronics, as seen at Fukushima. Mobility issues, heavy machinery required to move thousands of tons of collapsed concrete cannot easily navigate or operate autonomously in chaotic underground rubble, and lack of precision. Robots cannot perform the microscopic chemical separation needed to extract uranium dust that has been blasted into concrete and dirt. Okay, so
Okay,
that's it.
can I reply to that?
All right, sure. To go to the other people as well. Yeah.
Okay, then you need regime change because there's no way with these Durkas in charge that you're going to be in there for years.
Yeah.
That would take at least 6
Yes,
months, at
you're
least.
right.
And I'm going optimistic at 6 years. You have to have regime
Yes.
change. These people are not going to agree to have us there. They're not going to deliver. They
Nope.
can't deliver it. They're not going to agree to have us there. They'd attack halfway through the agreement. You have to have regime change. There's no other way. I also had a very quick update on those 13 people that got blown up by the unexploded ordnance. It seems that ordnance was very high-tech bunker buster ordnance, and that's why they were trying to get it out, because they were trying to sell it to the Chicoms. I had a link on it. I'll link it after I mute myself. But just a small update, they should have used robots to get that bomb, just to say robots are still cool. But they tried to do it themselves, and they blew themselves up.
Oh my god! By the way, guys, when you say Chicoms, it confuses people. Many people don't know yet you're talking about
Chinese
China.
communist. I
Yeah,
meant
I
the
know.
Chinese
Okay, so
communist, not the
maybe
good Chinese. We love the good Chinese.
yes, say Chinese communists, because there are people in our audience that are confused sometimes, right? Thank you. But yeah, I completely agree with you, by the way.
Okay, to respond, we have Jose and then Jeffrey.
Okay. Armin, Jeffrey, how many sites were targeted because they were potential nuclear sites that were doing enrichment? Because
3.
that also creates a problem big time.
3. So it was
3?
Natanz, Fordo, and the enrichment facilities at Isfahan.
Okay. And Armin, I understand all that. I agree 100%. All that is possibility, what you were talking about. But how sure are we that everything was collapsed on there? Because if they were deep enough, we don't know how deep the damage is done. You don't do that. You don't get that until you look into it. From up top, you can see that there's a bowl and something collapsed in, but it collapsed all the way in. Could this stuff be sitting in what's left of a room underground, like an Egyptian pyramid, where you have a room inside? Everything outside is wiped out, but the inside is still there. That's my thinking. It's one thing. It could be overthought, or it could be even worse than we're thinking. And yeah, that's it.
If you want to go by what President Trump is saying, then they're deep underground, and the Islamic Republic itself cannot reach it. And again, remember, we don't know exactly when President Trump, when he says something, is he playing mind games or not? But that's actually what he's publicly saying. Okay, but we don't have the exact down to the inch public measurement, but we do have satellite imagery and weapon. We also know the capabilities that the weapons have. They give us a clear picture of that the penetration was like deep, and it was like catastrophic. So we know that based on satellite images and what we know these weapons are capable of. Let me actually look at this. In Fordo, the facility is buried under roughly 300 feet of solid mountain rock. So we know it was there, right? And we know, so the US used 30,000-pound GBU 57 bunker busters, likely dropping them sequentially in the exact same spot to drill through the bedrock. Satellite images show massive craters on the mountain ridge, confirming the bomb successfully penetrated the rock layers and detonated directly inside the centrifuge hulls. So we know that about Fordo. In Natanz, for example, satellite imagery shows massive 5.5 meter diameter craters blasted straight through the earth and protective layers. Analysts confirmed the bombs penetrated directly into the subterranean enrichment halls and cascade areas. So basically, the bunker busters didn't just collapse the tunnels, they successfully drilled through up to 300 feet of earth and rock to detonate inside the facilities, completely entombing the infrastructure. That's what we can guess based on the satellite image that we have. You're muted if you're speaking.
No, I will speak. So we could have 3 totally different situations on each of those. That's all you just filled me. That's what you just told us. Okay. But I think we need to understand something. If it's been totally obliterated and scattered throughout all that area, and it is uranium, okay. I forget the half-life of uranium. That's old school, and I don't remember that stuff anymore. Way too old for that. But it might not be a good idea to go down there for that because of how much work you have to do. And if the Iranians, the regime, if it doesn't fall and they go down and get it, good luck, suckers. You're going to be irradiated real quick.
Yeah, you know what? Actually, that's a good point. The Islamic Republic not only it can't go to get the enriched uranium, it doesn't want to because I don't think they have the safety engineering capabilities to. Yeah, I don't know. Maybe they do actually. I don't know. By the way, the half lives of these isotopes of uranium. So uranium 235 is 700 million years, and uranium 238 is 4.5 billion years. If you're wondering about that.
Okay. And I just thought of something I saw on X. I think the last of the known Iranian nuclear scientists died of his injuries just last week. So they're dead, all of them. So the people that have the knowledge, they ain't there.
You mean wait? You're talking about Fakhrizadeh? Okay, yeah, Fakhrizadeh was the main nuclear scientist of the Islamic Republic. Was killed by Mossad inside Iran very effectively. His wife was sitting right next to him, and she didn't get a scratch on her. And the beautiful part of that assassination was that it was done with a robot arm with a gun on it. So there was no person shooting at him, and it was done with AI face recognition before AI became this big. So that was years ago, and it was done when Hossein Taeb was the head of IRGC's intelligence operations, and one of the main reasons why they fired him from his position. Yeah, remote. It was a remote machine gun. Yeah. It was a beautiful. His job so beautifully done. It was so impressive. All right.
All right, next to respond is Jeffrey.
Yeah, y'all touched again on really a lot of key points, right? So doing the post-strike assessment, it'll probably go something like this. You'll have satellite and aerial, like ISR first, so synthetic aperture radar, thermal imaging, optical imaging, all this other stuff, change detection, dust plume, blah, 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 like spoil piles and the rest of it. Then you'll have surface geophysics next, and that'll include things like ground penetrating radar, seismic acoustic methods to check for like voids and collapse zones, and gravity or microgravity surveys and density changes and all this other stuff. Then you have radiation nuclear material detection, which Armin talked about, right? So then you got to go in and see, okay, are they adulterated with uranium dust? Then you might use the robotic reconnaissance like small crawlers. And then what you end up sending is people like NEST and the NNSA. So forgive me. So NEST, Nuclear Emergency Support Team, DOE's NNSA is the Office of Counterterrorism and Proliferation. You have the aerial measuring system, and if I remember correctly, the National Nuclear Security Administration. Give me a little rope here. So what does all that mean? It means you are going to use all these kind of remote things to detect or probably assess the site. And then you have to chew through all of these gazillions of tons of collapsed tunnels that are full of ultra hard, like hardened high performance concrete and rebar and rock and everything else. And if you have the caskets that they contain their higher medium enriched uranium in it, Armin did a very good rendition of what some of the stuff that goes on. You're talking about stuff that's really radiotoxic. Its radiotoxicity is very high. It gives off emissive radiation. Even the robots that you send in, if it's concentrated and you have a lot of emissive radiation or neutron embrittlement, it fries the electronics. They actually had that issue in Chernobyl, right? So they sent robots in and it just fried the electronics. This is it isn't just send in Delta guys or even robots. This is a very involved project that will take a lot of effort, a lot of machines, a lot of people, and a lot of time. The reason we did what we did was to try and deny, because it's what also frustrates us retrieving the higher medium enriched uranium also denies the Mullah regime from digging it out and then using it, right? That's like why President Trump's it's buried under tons of rock. And there's a reason he said that. So where does it all leave us? You can't just leave it there because it's a persistent threat. It leaves us with regime change, just like everybody concluded. That's what has to happen. if you want to deny the regime remnants the ability to use legacy elements of their nuclear weapons program to pursue a nuclear weapon they have and get it out, then you have to eliminate them. Even if they decide to not do that route, they can get plutonium, turnkey systems, all this other stuff. So ultimately, it concludes with, just as Jose said, and just as Sketch concluded, regime change needs to happen if you want to make sure the regime doesn't get nuclear weapons, because they're never going to not pursue that shit.
Can I respond real quick? You also got to think that even with regime change, it has to happen because of the aquifers. That stuff is deep enough that radiation can get to the aquifers, and then you've got a zombie bunch of Iranians out there because they've been drinking water they shouldn't be drinking. You know what I mean? And water happens to be an issue right now in Iran.
That's actually a good point, because a lot of people were saying that the Bushehr facility is more dangerous than these for the environment, because I don't know why. So the Bushehr guys, remember the Natanz facility, the Fordo facility, and the Esfahan facility. That's where you enrich the uranium. Okay, but the Bushehr facility and a couple other facilities, that's where you turn the enriched uranium into electricity, which they have done that very poorly. We haven't have like after decades of the nuclear program, we haven't had much electricity at all, which shows that has never been it has never been about electricity. It's always been about nuclear bombs. But yeah, so let me actually see. Environmentally, it can be disastrous even if the radiation levels are relatively low. The environmental threat is permanent and okay, so you're right. Actually, this is really, I'm not going to go over all the details, but you're right, this is horrible. Okay, never mind, I'll take that back. Okay.
All right.